Let's do some additional examples involving the exponential function. Here's e to the 1 over x squared dx. We want to find the indefinite integral. So we use the method of substitution because we see this composition e to the 1 over x. So what we do first here is the 1 over x, and then we exponentiate that. So we're going to set u equal to this inside function. U is going to be equal to 1 over x. And du, well, that's the derivative of this. Well, 1 over x is the same as x to the minus 1. So the derivative of that is minus x to the minus 2, differentiating dx. Right? Reduce the exponent by 1, multiply by the old exponent. Okay, so that's good. So that's du and u. So what that means is that up above, we'll place u in place of 1 over x. Right? U is equal to 1 over x. And then now we have to look for where is dx and x squared. Well, x squared is, if in the denominator, is the same as x to the minus 2 in the numerator. That is, this thing is minus dx with a 1 over x squared in front. Okay, that's good because this is really the same as what we have here and here. We have dx, we have an x squared in the denominator. Here we have a dx and x squared in the denominator. The only difference is this minus sign. Okay, so we have to adjust for the minus sign. One way to do that is to take this equation, du equals this, and put a minus sign on both sides. That is, multiply both sides by minus 1 and get 1 over x squared dx. So this dx squared over x squared, this thing, is the same as minus du. So I can write a minus du in place of this and this. That's what this tells me. Okay, so then now I integrate this. And when I integrate, well, first I can put the minus sign outside. So I can write this as minus e to the u. The minus sign is just a minus 1. Okay, so the minus sign can go outside. Now the antiderivative of e to the u is e to the u. And then I have to add a constant. Last part, need to substitute the expressions involving x. So u equals 1 over x becomes e to the 1 over x with a minus sign plus c. Right? So that's it. Let's do another one. E to the square root of x divided by square root of x dx. Again, we're going to let u equal this inside function, in this case square root of x. We want to find du. Well, in order to do that, we'll have to take the derivative of square root of x, but we'd rather write that as x to the 1/2. So then the derivative of x to the 1/2 is 1/2 x to the, well, 1/2 minus 1 is minus 1/2. And then we write a dx. Okay. So now we want to substitute back in. E to the, instead of square root of x, we write u. And then we have to figure out what to do with the dx and the square root of x. But they're here. How are they here? Well, this is 1/2. And then x to the minus 1/2 is the same as putting x to the 1/2 in the denominator, but x to the 1/2 is the same as square root of x. So x to the minus 1/2 is the same as this, and then dx, just by algebra. And we see that this part is the same as this part. So the only difference between what I want to substitute in, which has got this 1/2, and this part is the 1/2. So I can multiply both sides by 2, get 2 du is equal to 1 over the square root of x dx. So now what's in yellow here is the same as what's on the right-hand side. So I can substitute what's in yellow here with 2 du. Oops, du. Okay, then I can put the 2 outside. That's just a constant, e to the u du. And now I find the antiderivative of e to the u, which I know is e to the u. I have the 2 comes along, and then plus a constant. Now I back substitute u equals square root of x. I get 2 to the square root of x plus c.